also up in Chicago where we have another office. Let's see. So let me just do this inception trick here really fast. And here. Cool. Can everybody see that? I can't see anyone else, so I'm just going to assume. Okay, cool. So
I'm popping in to say everything is good.
All right, cool. Thanks. So let me just run through this really fast. We implemented these 5 data-driven metrics, and you won't believe what happened next. I know making up titles for stuff is really terrible, and my apologies. Sorry, not sorry. So this is a dumb talk by me, mostly featuring XKCD comics. Those are all found on xkcd.com, so I don't have to have a link at the end. So anyway, metrics. What are they? What are we doing with them? Basically, the way I look at it, it's tracking or status of a thing over a time scale. So miles per hour, miles per gallon, any kind of thing where you're tracking a point in time plotted over sort of a time series. And the big thing you need to ask is, like, what's the problem you're trying to solve when dealing with metrics, and like properly define that problem, and not just like your boss wants to know, hey, can you make your team ship code faster? Like specifically ask specific questions, like, you know, what does faster mean, or what do you mean when you want to say it ships faster, with all the caveats that come with that. So the problem that we're looking at here is, how can I tell if an engineering team is working at maximum efficiency? And you know, there's a bunch of terrible ways to figure this out. Like, well, how many lines of code did this person write? Some of the best pull requests I've ever looked at in my life were way more deletions than adds. So lines of code added is a terrible metric, terrible way to measure the efficiency of an engineering team or a developer, more specifically. So I guess the big thing is like, measure what matters, or the important things. So define what that is, right? This is the slide that I'm going to probably spend the most time on, or the entirety of this talk. These are the things that we measure. PR ship per day, deployments per day, change fail percentage, acceptance criteria, oscillation, and time to ship. So I'm going to kind of unpack each one of those. So PR ship today, or ship per day, is pretty self-explanatory, and that's how many pull requests got sent over to QA, or, you know, code complete in a day. We found that this was a really good metric to measure sort of a rough output of a specific developer. And usually when people see this, they're like, oh, well, some PRs are bigger than others. And that's true. And I was really skeptical of this a few years ago when I started implementing it. But on a 50 developer team, when I launched this particular metric, I'm like, this is going to be terrible, because like this developer over here mostly just works on really small bugs and, you know, quick little things, and he might knock out 3-4 tickets in a given day, while this developer over here is like completely refactoring this API or completely rebuilding this thing from the ground up, and he might put a pull request out that's all feature flagged and, you know, behind some environment variable once a week, once a month. He might work on a thing for 6 weeks, and then it's just one big giant PR at the end of all that work. So that seems like, wow, that's going to be a terrible metric. But what we found in practice was, when it all gets washed out and you average it across the team, kind of the spikes and the highs and lows of any particular dev in any particular day, it sort of evens out. So if that developer that spent 6 weeks building this giant refactor, well, chances are there was probably a handful of follow-up PRs that came in fast succession once that thing was shipped and it made it into production. So it does flatten out over time. So on a larger time scale, it starts to make more sense. So that's really PR ship per day. Deployments per day. We at Kin, we actually sort of glue these two together. We generally deploy to production 2 to 3 times every single day. And in those 2 to 3 deployments are 4, 5, 6, 7 tickets or pull requests per deployment. I have them broken out because the way that we sort of glue them together is a little weird. But it's important to know how often that you're deploying. That's another metric that really acts as a proxy for developer efficiency, but it's really more of a proxy for your entire development team, the entire engineering team, which includes QA and product and maybe a few other business types. So really, it's deployments per day. How often are you deploying? And if you don't deploy every day, record it as a 0 and plot it over a larger time scale. Change fail percentage and restore time. This basically means if a developer said, I'm code complete with this, and sent it over to QA, and QA kicked it back and said, hey, I found a bug, or I found a problem, or this isn't meeting acceptance criteria, that's considered a fail. Or if it actually made it all the way out to production and we found a bug or something, how long did it take to fix that bug is part of the restore time metric. We also glue those two together to come up with this change fail percentage. But the simple one is what percentage of tickets have to come back. And it doesn't have to go all the way to production. It can be just coming back from QA. So what's that percentage? Acceptance criteria oscillation. This is really a measurement of, I'm sure anybody that's been a developer at any team for long enough knows that there's always a problem with product where they're like, hey, we want this new feature where when you click on A, the B thing happens. And so the developer starts working on it and they get most of the way through it. And they're like, well, wait a minute, when I click on A, the B thing happens, but also the B thing happens if I click on B. And he didn't specify what was supposed to happen if you click on B. So then you tell the PM that, and then the PM comes back and says, oh, I'll just update the ticket to include these new requirements. So we measure specifically how often that happens. And we do that. We use GitHub Issues for our issue management system. And we do that by watching how many times the issue description text is changed once that ticket goes into in progress. And some people say, oh, well, that one time when the guy just like added a period to a sentence and like changed some wording, some stuff that didn't really functionally change how the feature was going to get developed, but it was still an edit, and we count it. And again, on a larger time scale, that stuff evens out. That noise floor just goes away. And meaningful data comes out as a result. So that's acceptance criteria oscillation. And then also time to ship. So product or business comes up with a new feature. Hey, we want to add this thing. The time it takes from it's in the backlog to it's in production. And, once again, there's caveats to all of these, which is, hey, this took a really long time and it was a big giant feature. I would submit that feature should probably have been broken up into smaller items and had more and more pull requests associated with it, putting that stuff behind a feature flag or something. But yeah, bigger things take longer to ship. Smaller things take a shorter amount of time to ship. But again, what you'll find is on this larger time scale, you'll start to see patterns in the data, and it really starts to make sense. I was super skeptical a lot of these things. But when you start to plot it and look at it over months and eventually over years, you'll see, oh yeah, I can see where this really senior developer went on vacation and we took a little bit of a hit here. Or I can see when we hired these new people, we actually took a hit in productivity because hiring a bunch of people is a bit of a drag on your development organization. But then once those people get up to speed, then you get a net gain. All of that stuff becomes visible when you measure frequently and make sure that it's accurate. So that's kind of what we do. Like I said, there's a whole bunch of caveats. When you start to automate stuff, don't get too far into the weeds and like make sure it's accurate, but don't go crazy with how you're reporting it. Like figure out how to get the data and just stick it in a spreadsheet for a while. And then just maintain a spreadsheet for a couple weeks and see what that looks like. and then once you're sure that you're tracking the correct data and you're accurately capturing it, put it into a more automated way. Build it into a GitHub action or build it into GitHub or something like that. So yeah, that's kind of all I've got. Any questions on that? How do I stop sharing? I don't know. Maybe that. Yeah. Questions from anyone? All right. I'll take that as a no. Thanks for your time, everybody. Hope you enjoy the rest of the conference.